So thank you. Okay, so I think it'll just be nice if we get to just review what we did last week. And so I'm just going to share my screen and then just talk a bit about what we did last week for the benefit of those who tried to be here, but Zoom had some other ideas. So let's go. Share screen, and I'm just going to share this right away. Okay, so last week we began talking about some Python tips that could help your productivity in the world of coding. So yeah, Python has a lot of shortcuts and a lot of hidden tips and tricks that when the thing about these things are that sometimes when you see some libraries take these tips and tricks like the norm. For example, if you try to use this graphing library called matplotlib in Python, like the most popular data science graphing library, you would notice that they do a lot of unpacking, a lot of I'm trying to remember the name they call that now. I think they call it asterisk grouping. And there are a lot of things that those guys do in there that if you're a newcomer to Python and you just jumped into Python for data science, I just got maybe your data camp course or something like that, you probably are going to get very confused. So those are the things we're trying to look at and then try to see how we can clear out them. So the first thing we looked at was slicing. Now, let me use this same, the same one we did, but practically all the examples are there. So I probably am going to delete all these examples, because they are already contained here. You can see some of them here. So I just want to repeat like the code and then make it like a revision for one or two people who Zoom didn't kick out last week, right? So now you have a list called numbers, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10.
Excuse me.
Now, go ahead.
Please, could you share the collab link again?
Oh, sure, I can. I'm going to do that right away. And
thank you.
Okay, so there you have it. It's in the charts. All right, so you decide to say, okay, now I want to take like the first 5. Python has something called slicing, with which you can select any amount of items in a list, all right? And you can also, as in you can select it anyhow. Probably you want to select every nth item, like every second item, every third item, or anyhow if you want to select the list. Python allows you the flexibility to do that through slicing. All right, so let's see how it works. Now, let's say, I'm just going to run this. Let's say I want to get the first 3 items in this list. All right, and this doesn't work for just lists alone. It works for dictionaries, it works for tuples, it works for practically all major data types or object types in Python, but there are just tweaks here and there, like for dictionaries, which we'll look at shortly. But let's look at the one for lists. So let's say I want to slice the first 3, all right? And when I want to slice the first 3, it means I want to create another list, technically in quotes, like, from this one. So I'm going to tell Python, okay, hey, Python, I want you to tell me what numbers, and this is the syntax for slicing. The syntax for slicing is start, as in where you want Python to start from, the stop, where you want Python to stop, and then the step. Now, when you when you're using the slicing and you put just the number, let's just say you put one, let's say you put number one, all right? This number one is just going to give you the item in, why are you not printing? Come on. It's just going to give you the item in this position here, all right, which is 2. Remember, Python is a zero indexing language. So it's just going to tell you, hey, I'm going to start from here, all right, 0, 1. Now, if I say Python, give me what is in number 6, as in the index position of 6, Python is going to tell me it's 7 because it's 0, 1, 2, 3, 4, 5, 6. All right. So if I want to get what is in the first to the 5th, I will have to stop at 6 because since Python is a zero-based language, on the right side, which is the end part of the index, it's going to knock off 1, all right, because it's starting to count from 0. So I'm going to run this now, and Python is going to get me what is an index number 1 from the 1st, 2nd, 3rd, 4th, 5th, and the 6th item. So, you know, when you tell Python, give me 0 to 6, between these two numbers, actually, there are 7 numbers, 0, 1, 2, 3, 4, 5, 6, 7. But Python knows you need 6, all right? So when you stop at 6 there, Python knows, okay, this guy wants the 6th item. So let me just knock off the last thing, and it gives you only 6 items, even though you have indicated you want 7 numbers here. All right, so that's the way it works. If you want 6 things and you indicate 0 to 6, it knocks off the 6th, all right? Now, if you want 0 to say 8, you can, so it knocks off the 7th. So what we just did now is called positive indexing, all right? Because we look at the list or the tuple or whatever it is, the first object, 2nd, 3rd, 5th, 6th item. If you're going in the direction of the positive, it's called positive indexing. But if you're counting down from the end to the beginning, it's called negative indexing. So this item here, which is 1, actually is item 0 when you're counting positive, but it will be item 9, I think, or item 10 when you're counting down from the negative, minus 10, all right? So we're going to show that right now. But I just want to show you the last 10. So you can see from here, we have said, okay, so so Python starts at 0 and then stop at 8. But what if we want to count in steps, right? So we want to say, okay, so Python, I want it to jump and give me every nth item. So every 2nd item or every 3rd item. So that's what we do here. Just put it here and you just say run. So you're telling Python, give me every 3rd item. So it's just going to go 1, 2, 3, 4, 5, 6, 7, like that. All right, if you change this to 4, it's just going to be the same thing. You're going to have just 1 and 5. So if you change this to 2, it's just going to return the same thing. And the beautiful part of this is that anywhere you can use an index, like if you want this, anywhere you can use an index, you can actually use a slicer. And that's amazing. It's amazing. It's a game changer for your code if you learn how to use it. So we've just looked at positive indexing. So let's look at negative indexing. Now, for negative indexing, we can start at, say, let's say minus 10, all right, to minus 1. Remember, minus 1 is the last, all right? And then this one here will be minus 10. Okay, let's even make it minus 5. So you see how it works. All right, so when we run this, see what we get. 6, 7, 8, 9. So remember, it starts from the last. Again, 0 index knocks off 1 out of the upper boundaries and then tells you how you get it. So if you do minus 6, you get this, all right? But what if you do 0 here? You see what happens? 0 is not recognized as a bound in negative indexing. So you have to come from -1, all right? And then, I know in your mind, you want to ask, what if we do -0? Let's see what happens. Same thing. Okay, so, but one way to deal with this, because using negative indexing, you can see, because 0 obviously is not a negative number, and Python is a 0 base, and that's why you're having this problem, because there's nothing like -0. So there are other ways with which you can deal with this problem, all right? You can use functions like len and all of that. So we're going to look at that shortly. Okay, so let me see one other example we did last week. Okay, so one way you can do negative indexing too is you can start at the upper bound. Let's see what happens when you start here at let's say you say minus say okay. Now let me do this quickly. Okay, so you know when you say you want to get, okay, let me just do this first. Now I'll come back to this. One of the ways you can get the bounds of an object, a Python object, is by using this len, all right? So you can actually just say, okay, so I want to get the length of this item numbers. And when you run it, it's going to tell you how many objects or how many items are in that object. So it's telling you have 10, all right? So you can actually say, Python, I want you to give me numbers, sorry. I want you to give me numbers, all right? Slice it from the start, which is minus len numbers. Remember, minus len numbers counts everything in every item in the list, all right? And stop at the first. So this way, you don't need to keep counting. Okay, I need to count how many we have here. We don't need to do that. So when you just run this, oh, sorry, it's not supposed to be this. It's supposed to be a square bracket, right? So this is what we'll have. 1, 2, 3, 4, 5, 6, 7, 8, 9. So again, you notice that the last number is not accounted for because, yeah, well, we did not want, because of Python's problem, the zero-based problem. So we've dealt with positive indexing, we've dealt with negative indexing. Let me see what else we did last week. Okay, so we talked about how slicing works with other objects. So for those of you who are in data science, you probably have heard of this library called pandas. It's a very notorious library. So I'm just going to import it. Import pandas as PD. And yes,
is pandas already in the collab? Or must I
yes.
install it?
No. You have to import it. It's already in Google. It's already in the cloud server where you're working from. But
okay, so I can just go ahead and import.
Yes, just write imports and you'll be fine.
Okay.
But if you run, if for any reason you run any library in Python and it doesn't work, all you need to do is just pip install it. So let's assume I run a library and it's not like PyCaret and a couple of other libraries like that are not in Google servers. So you'd have to just use an exclamation to show Python you are giving it a command, an imperative. Pip install pandas, all right? So that's what it's going to look like. Pip install pandas. That's if you have not had it already, or if you try to import it and it tells you it doesn't see the library. So that's what you do. And when you do that, it automatically installs it for that runtime, which means that the moment you close your collab and you open it again, you have to do pip install again because Anything Google did not install in their server, they don't want to have it there forever. They just want you to install per time, and then when you're done, they discard it. Okay, so for this one, I'm just going to say import pandas as PD. Then I'm just going to take this GitHub address and just copy it. And okay, so I'm going to call this data set, and this data set will be equal to so PD, which is pandas, the alias for pandas, dot read CSV, because it's a CSV file we're trying to read. All right, so we're just going to use this read CSV method. And once you open the brackets, the parameters you need are going to come out. So what you need is like a path, a file path. That's if it's a local file, or if it's from a URL, then you probably want to supply that. All right, so when I just supply this, then I can run it. Okay, cool. So there we have it. Now I can say datasets dot head to get me the first 5. All right. But remember, you can always increase this to any number you want, basically. So you're free to put any number you like in that bracket. All right. And Python is going to return that for you. So now let's say we want to slice, or we want to refer to rows and columns. Pandas has 2 methods through which they refer to rows and columns. One is called the lock, and the other one is called ilock. All right. So what is the difference between the 2 of them? Let's just do this. Lock and ilock. Now, the difference between the 2 of them is that this one is a label index notation, and then this one, label notation, and this one index notation. So this is how it works. Now, let's say, like as you see this table right now, this table has labels in the columns. So this column is labeled as P class. This one is labeled as sex. This one is labeled as age. This is labeled as survived. All right. And those are the labels basically. So when you want to refer to these, you have to refer to them through the labels. So for example, let's say I want to refer to these, I want to get just the P class, that's a passenger class. So all I just need to do is to slice, all right, just the P class. So you can see already Python has given me the option to slice that. Now, when I run this, it's going to slice that label for me, just that, all right? The whole row, you can see the whole 528 rows of data there, okay? So it's the same thing we do when we say numbers 0 or numbers 1. We're asking Python just give us 1 or give us 2, all right? So now, but because pandas is, deals with a lot of rows, when you want to reach into rows, all right, normally you should be able to do this. P class to, let me see, sex, let me say age, all right? And normally you should be able to do this, but you can see pandas is not allowing you to do that because it's saying, yeah, I can't allow you to do this because of the nature of the object. So how does pandas allow you slice? By using this lock and ilock. So let's see how lock and ilock works. So ilock and lock are methods. And when you just put them, you start with lock. You are telling Python, okay, now I want to slice. So the moment you put this lock, you can even see that the what do you call it now? Intellisense, I don't know what you call it in Colab, I've forgotten. but in Microsoft's ecosystem, it's called Intellisense. So what it's doing is just giving you suggestions, right? So you notice that automatically they've told you that what you should have here is a list. That's why you have this square brackets you see here, all right? So once I put it up here, Python now is expecting a list, but it's expecting that list in label form. And remember, pandas is like a spreadsheet, rows and columns. So the first part in pandas, any pandas syntax you're working on always refers to the rows, and the second part refers to the columns. Please don't forget this, very, very key. All right. So now let's do this. So this, I'm going to just put the rows, and this syntax works again. This syntax start, step, stop. It works. I'm sorry, I'm scrolling. All right. So so let's go start with the rows. Now these are the rows 1, 2, 3, 4, 5. So let's pick the first 5 rows, but Python needs their labels. So if we want to pick the first 5 rows, it means we want to start at 0 and stop at 5. So we want to tell Python start at 0 and stop at 5. That's for rows, all right? But for columns, remember, this is lock. We're looking at labels, not index. I'm going to show you the difference shortly. So for this one, we're going to supply the index that we want. What the Python give us from P class, all right, to age. Okay, so we've supplied the row, we've supplied the column, all right, and yeah. So let's run this. So see what Python has done. It has supplied us from 0 to 5 and from P class to age. Remember, what we are using is label notation, not index. So let's use index and then let's see what the difference is. All right. Now we're going to say dataset dot iloc for index, and we're going to use the same thing. Okay, 0 to 5 and P class to age. Okay, now watch what's going to happen. I'm going to get an error. And why am I getting an error? Because this is index location, not name. So Python is not expecting this name. So I'm now going to remove this and remove this. And I'm going to put the index range of this, the cells I want. So 1, 2, 3. I'm going to start from 0. And then I'm going to put it up to 4 so that Python can knock off the last, all right, and give me 1, 2, 3. So let's run this and see what we get. Oh, sorry. I will tell you why that happened. Why that happened, why it brought out 4 is that it counts this also as one of the rows, the columns, right? Index column. So this is it. Dataset iloc uses the index numbers, all right? But you will notice that this one is 0 to 5, but it gave us just 4. While this one is 0 to 5, it gave us 5. And that's the thing. This one is a label. So in this case, Python is not counting the indexes. It's just counting the label. It's giving you from what is labeled 0 to what is labeled 5. But in the case of iloc, it's giving you what is in the index. All right. So that's how it works. And guess what? You can still do the same slicing here. So let's say you want just say the stuff to jump every 2 rows and this one to jump as in the step every 2 columns. So give me 4 here, but jump every 2 columns. That's in steps of 2. So when I do that, see what happens. So you see 0, 2, 4, and 6, 8. If you want that to show up, you can always have it to show. And if you do this, you'll see that it's jumping like P class here, no sex, age, like that. So it's the same idea. Slicing works everywhere. All right, it works everywhere. So remember, you can stop me at any point in time if you have any questions, and I'll be glad to answer them. Okay, so so let's go on if there are no questions. Now, what else did we do that I'm just going to repeat? We did that slicing. Okay, so how slicing works with dictionaries. So let's go show how slicing works with dictionaries. All right, so let me start that here. Now, let's create a new dictionary and let's call this class dictionary. Okay, so class dictionary. All right. So let's have this here because since it's a dictionary, we'll always use the curly brackets. Now, let's say we want to have the names of the people in class and their registration numbers as the key while the names are the values. So let's just assume that the person we give reg number 0012 is John and reg number 002 is say Tina, reg number 003 is Oge. So, all right, so this is our class dictionary. Now, if I say Python, give me class dictionary 1, guess what's going to happen? It's going to give me an error. Why is it giving me an error? Again, because dictionaries basically are not subscriptable like this, all right? Because they are a key and value pair. So one of the things that I can do is to make this a list. This class dictionary, I'll make it a list, and then I'll try to subscript it, all right? So now let's make this sorry. I think I know why this error happened. Because I put the number, okay, I put the number 1, all right? Now, if we put the label, which is the key, all right? If we put the label here, it's going to give us this, which is like, it's not really what we want. We want to just subscript the number and say Python, give it to us, all right? So what we can do is, we can, 2 ways, like I shared with you last week, we can make that dictionary a number, or we can use, okay, let's use this one first. Let's make this dictionary a list first. So let's call this converter. Let me just use, okay, let's just call it a B. Let's call it B, since we have A down there already. So let's convert this dictionary to a list first. So we'll make this class dictionary, and then we'll run this. So now when we just push this down a bit, when we tell Python to print B, let's see what it gives us. It gives us just the keys, all right, of these dictionaries. So when you tell Python to convert a dictionary to a list for you, the only thing it takes are the keys. So now you can use these keys, all right, to reach into this dictionary. So you probably can just say B, which is now a list, B1, all right? And it still gives you keys. B2, B0. So we have gotten the first part of what we want. Now, the second part of what we can do now is we can now use these stuff here to reach into the list, all right? And then get the item, okay? So we can use a for loop, we can use different methods basically. But one of the methods that you can use is .get, all right? So yeah, you can use the .get method, all right? I'm going to come back to that shortly, but let me do this. I'm thinking, okay. So if you want to get the value from here, all right, using this key, what you can now do is you can either say B0, which is this dot get, all right? Okay, so we're going to have to go back to our original dictionary. So we're going to have class dictionary, which is this, okay, dot get, right? Yeah, and then dot get is going to ask us for the key, and the key has to be a string. So here we can now supply what is in B0. All right, and let's see how it works. Cool. So that's it. And we can supply what's in B1, and we get that, all right? And the beauty of it is that right now, you can now use a for loop, or you can now use a variable, or anything that you need to, just name all of these results as, and then you can now call it in. And that's the next thing we're going to look at right now, how to use a list as like a supply, like a constant supply into a dictionary or something. Or before we do that, have I finished what we were doing last week? Okay, yeah. So last week we also looked at the difference between return and print keywords in a function. So I just used this example, and the example I used was, so let's create a function that creates an uppercase. So we could call that function create upper, all right? And then the function takes any text. Remember, what you have here is just a placeholder. It's nothing. You can write anything here. You can write John, you can write Tima, anything you want to write, all right? It's just a placeholder. So what I want to do is I want Python to take whatever is inside of here when this function is called and return the uppercase of it. Now, if I use prints, all right, the function or the method that returns uppercase is text.upper, or whatever the object is inside of here .upper. But you would notice this squiggly lines, this squiggle here telling us that there's a problem. And the problem here is that Python thinks that this is a variable that has not been declared, all right? So because it's not been declared, Python doesn't know what it says. But hey, Python, I've declared this here. You should have this here. Okay, so Python is like, well, I can't print a function, all right? You can only return a function. So that's one of the gotchas you have to watch out for when you're working in Python. When you need a function to return a calculation or a value or something, you don't use print, you use return, all right, or yield, or any of all of those functions that we'll look at much later when we go full into OOP. So this is what you'll notice, that the squiggle has disappeared. And then when I run this, I can now call this function creates upper on the name John. And when I run it, bam. Oh, sorry, prints. So it's, come on, return text dot upper. Okay, what's happening here? Def create upper text, return text dot upper.
If you run that same print line
Yes.
in 37, but don't indent it,
Okay,
will that print it?
this one,
Right, create a new
you want me
line, but
to-
don't indent.
I should do this.
No, keep return indented,
Okay,
but then create a new line that is not indented, a third line,
okay,
that is the print statement.
okay. Then print, all right?
Right. Now do your
Okay,
create
let's see how
upper.
it works. Okay, so print create upper. Okay, so let's see how this works. Okay, so technically this is a function call. The moment it doesn't have that space, it becomes a function call. So that's what's happening here. That's why it's telling us create upper requires one argument, which is text. So let's say I supply the text here. Go ahead.
No,
Go
that's
ahead,
what I was
John.
gonna say, you just gotta put John in there. You're just
Yeah,
doing what I was
let's see.
suggesting. Yep.
Okay, so it still gives us this. And no, it shouldn't give us this. So text, we create upper text, all right, and return text dot upper. Wait, let me see. What did we do last week? Yeah, same thing. And yeah, this is one of the problems I have with Colab, because you can see same and it's not returning. Okay, so okay, so let me see, run this again, and let's call the function create upper, and let's put in the text, John. Let's see how it works. Okay, function. It's not supposed to return this at all. All right. So like this is it. You can see the function we used last week. And then we run it. And you can see it's the same thing, exactly the same thing. I'm not changing anything. All right. Oh, I think I know why it's not working. Somebody just whip me. Anytime we're doing a function inside, anytime we're doing a function like this, we're using a method like upper, we have to supply those brackets. So yeah, that's why it's not working. Okay, yeah, somebody flogged me. Okay, so yeah, so that's it. Now, so that's basically the difference between return and print. All right. So thank you, John. Thank you. Now I'm going to look for what's the okay. We did enumerate. Yeah. So let's work on this. I think this was the last one we did before we had to take the break. Okay. So let's just look at what enumerate does. I'm looking for the best place to put that so that I don't cause problems. So I'm just going to insert lines here, and then now what does enumerate do? Enumerate creates a tuple. All right. So if I say an enumerate range and which other function? I think there are three built-in functions that return numbers. There's enumerate, there's range. I can't remember the third one now, but I'm going to remember it, I hope, before the class ends. So let me just remind you how this two work. Okay, so there's a X range. Okay, I'm going to try that. I'm going to try that. I will try it. Okay, so let's show how this two work. Now, for enumerates, let's say I say for, okay, let's start with the range for I in range, say 10. Remember, anytime you're working with numbers in Python, you can say start, stop, step. All right, so same idea with the slicing. So let's say Python will want all the numbers. If we do not supply the start, and we just put this 10 here, we're telling Python start from the default and end at 10, all right? But if we put the start, let's say from 1, I'll tell Python stop at 10. It means we're telling Python to just give us the normal, I'm starting from 1. So when I run this for I in range, this prints I. I'm just telling Python, you just look through. Come on, what's happening here? For I in range 1 to 10, prints I. Okay, let me see. Expected closing brackets. Okay. So let's say from I in range 10, prints I, because Collab looks like it's very ill today. So yeah. Oh, a bracket is missing, sorry. Print I, all right? So let's print I now. So it's going to give us this 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, all right? And then I could say from 1 to 10 and jump in steps of 2, all right? So, and I don't know why it keeps doing this. Because I'm supposed to be able to do range and start, stop, and step. I'm supposed to be able to do that. So why is it complaining? This 1 to 10, okay. Why the complaints? Let's see. Why expected? Yeah, it's there. Okay. Okay, wait, let me put this in a list. I think that's a problem. Lists. Let's see what happens if it stops complaining. Still complaining. Okay. Very sorry. Because this is supposed to be straightforward. Like start, stop, step, and right, come on. Okay, so let's look at the examples again. Let me see. Come on, bring it out. Because I want to take the examples. No, I don't want to do this. Start equal to, I don't want to do this. Stop equal to 10. I don't want to have to do that. Okay, so let me see what happens here. Let's see. Okay. Okay, so, okay, well, and let me just see if this keyword argument works. Step equal to 2. Let's see if this works. It doesn't. It doesn't work. Because according to her, range takes no keyword argument. So, well, let's leave it at this until we can know what is wrong with Collab today. All right, so we have this, all right? Now, if I were to use, an object like this list here, or let me create an object. All right, let me just create a list. I'm just going to call that list class names. And the list is going to be John and Harsh, and who else is in the class? C. Okay, I'm use Kasim. All right, now, so I'm just going to use 3 names. So if I use enum here, enumerates, and I ask Python to enumerate what's in class names. Sorry, let me run this so that's two available. Class underscore names. All right. So I said print I. So let's see what happens. So this is what Python gives us. It gives us the name and it attaches an index number. So that's what it does with the number it generates. It attaches an index number, right? So now you can decide to have this in a list, all right? In which case you probably just even do this. Just say enumerate class names, and it just gives you, okay, print, let me say lists, enumerate class names. So it will just give you the numbers, this whole thing as a list, all right? You can also make it a dictionary. Now, I don't think you can make it a dictionary directly. Let me see if this will work. It worked. Wow, okay, okay. But we had to last week go through the rigmarole of creating a dictionary blank value and then use the for loop to append it into the dictionary, and yeah. So sorry, but when you see what we did, we had to create a blank dictionary for the values and for the list, and then it's sad. It was a long journey, but hey, why did this not occur to me that I could create it directly? Okay, so now that was basically what we did last week. And at this point, if anyone has a question, I'll be glad to take it. If anyone doesn't have a question, I will be glad to continue. So, question, anyone? None? Okay, so let's go on. Now, let's take some more, let me see these are lists. So I have enumerates, how to use len to get the upper bounds of an object, okay? So yeah, basically I've shown an example of that while I was doing this len, okay? But you can also do this. So let me just put that here. You can also do this. So let's say you want to, let's have this object called let's have this list, the same list we have here, class names. So say for I, or for name, my usual preferred method, in class names. All right, so Python, what do you want to do? Let me see, print. Now, what I want to show here is that you can actually tell Python to print more than one thing. So I can say print name, and then print name, print class name. Is this class names? Let me say name. Okay, so let's do it this way. So sorry, class names. So this is what I'm trying to do now. Yeah, when I run this, all I just told Python to do, class name, Let me see. Okay, so it's telling me this thing is an integer. Okay, let me put a range object here. Let's see whether it gives me what I want to do. Let me run that. Oh, this is a problem. List cannot be interpreted as an integer. Okay, I think I get. Oh, there's a problem. It's no len. Okay, should work now. Right here. So this is what I wanted to do. I wanted to print the name and then yeah, I wanted to print it like this without the brackets or the quotes. So yeah, so this is what I did. I just told Python, when you look into range means remember range returns a number. So all the things we have here is going to return a number for us. So look into the length of class names. That's what we're telling Python. So class names has just 3 items. And then it means that you're going to loop 3 times. So for I, let me use I here so it doesn't confuse anyone. So for I in range this, so for every number in this item, all right, which is 3, print I. I'm going to change this to I here too, and then so I is the number 1, number 2, number 3 as in the number it gets, and print the name that is in that place. So that's basically what I tried to do here, which is this. So print the number, which is this I, and then print the name, all right, that is in that number. So for the first one, which is 0, go to the class names and get us what is in 0, which is John. For the second one, which is 1, go to the class names and get us what is there, which is Harsh and then Kasim, right? So that's how this works. If you have any questions, I'll be glad to take them. But if not, I'll also be glad to continue. Okay, now, another thing that you would see a lot of times in Python is Lambda. And what is Lambda basically? Lambda is a throwaway function. Now, when you want to create a function normally in Python, all right, you want to go def, all right, create upper, and you supply the parameters. So let's say you want to supply X and Y or whatever you like, whatever the parameters are, and then return, say X times Y or whatever you want it to return. So this is how you create a normal function. But what happens is this: the moment you create this create upper, Python creates like a permanent space in its memory for this function. Now, if you are writing a very massive library that will have a lot of functions, you want to minimize the size of that library. So what happens is that most people now use anonymous functions where this function that they are creating would be required only once. So if this thing I want to do will be required just once in the lifetime of my code, this whole 500,000 lines of code I want to write, then why do I want to create a function that will just go and hang somewhere in Python's memory, and continue consuming memory space? So why don't I create an anonymous function that immediately Python uses it at runtime, it discards it and doesn't have to worry about memory, right? So that's why most people use Lambda functions. And yeah, so this is how it works. A Lambda is a regular function, all right? So it also receives arguments or parameters if you like. And then after you supply the parameters, you tell Python what it is you want those parameters to do. So for example, I want to create a function that takes a number, all right, which is X, and then doubles it or multiplies it by 2. So I would say what I want the function to do, x times 2. And when I run this, it tells me, yeah, that's the function. So when I use this in a function or in a variable or in any other thing that I use it, Python just knows what I want to do. So let me use this. Let me just name this lambda as a variable. So I'm just going to name it class lambda, and it's just a variable name. All right. So what do I want class lambda to do? I want whenever somebody makes a reference to class lambda, it should ask the person for the number of parameters here. Maybe this one just wants 1 parameters, but you can have 2, you can have 3, you can have any number of parameters that you want, and then it will do this. So when I say class lambda, and I use, say, 10, this is what Python is going to return, 20. So it takes whatever is here and then multiplies it by 2. Now, most times where you would see lambdas being used are inside of a function like this create upper, or you would see it inside of another function. Okay, so there are a lot of built-in functions in Python that cannot stand alone. So most times you would see people use lambdas with those functions. I'm going to show you 1 or 2 examples and I will prompt you for questions. Now, so let's take this example. Let's use the example map, all right? So this function called map is an inbuilt Python function. Now, what does it do? It takes one function and applies it over a number of iterables. And by iterables, it means something that you can iterate over, lists, tuples, and all of that, all right? So it takes a function, then you have your iterables, and then, so that's how it works. Now, let me see, 3, 4, 5, 6. If there's anything we'll name, nothing. Okay. Nothing interesting here. Okay, so let's put, let's create a list now. And let me call this list number 1. So this list is 1, 1, 1, 1, 1, 1. And then I'll create another list and I'll call that numbers 2. And this list is just 2, 2, 2, 2, 2. All right, so that's fair enough. So let's see, I have a function, all right? I want to create a function. Okay, let me even just create the function. So let me call that def multiply. And this function, what it does is it takes whatever parameters there. Let me just pretend just 2 or any number of parameters. So I'm just going to put this there. All right. And return. Okay, so if I do this, I'm going to have to make this function very long, and I don't want to do that. So let me just do xy. And then I'm going to now return x times y, all right? X times y. So that's what I want to do. Now, I can decide to, if I want to run this on a normal day, I'm going to show you a trick in Python. Now, remember I did not specify okay, let me do this. Return x times y. No, let me not do that. Let me do, okay, let me just make this one parameter, all right? Just one parameter, X, only one. And then what this function does is that it gives you the X raised to power 2. So let me call this function, let me call this function multiply. Let me call it multiply, and let me put 5. So when I run this, it will give me 25 because that's what it does. Okay, great. Now, let me show you a Python trick using this map function. All right. I might want to apply this function across a list of iterables. So instead of saying, I will call multiply and say multiply here, put multiply number 1. First, will this thing work? This thing I want to do now, will it work? No, it didn't work. Who can tell me why it didn't work? Anybody? Anyone? Okay, okay, do you want to try? Okay, Kasim, go ahead, Kasim.
I feel maybe because of the parameter.
Oh yeah, it's a list. And because it's a list, you really cannot multiply a list, all right? But we can get Python to take everything inside of here by doing just one simple thing. Should I show you what it is? This is it. Just put a star in front of the name of the iterable. And when I run this, oh, it takes 1 or 5 for a given. Okay, so how do I go about that again? Let me put this here in front of this function, run it, and then let me run this. Okay. So, let me see, multiply number 1. Okay. Now, this is forcing me to have to it's forcing me to have to do this. Okay, so I'll have to. I can't dodge it. All right. So let's make it args. And we start our counter at 1, and then for num in args, counter equal to counter. Okay, if I say counter raised to power 2, then return counter. What it's going to do is it's going to say okay, let me see if it gives me what I want. No, this is no. Is this what I want? Okay, so let me see if, so what it does is counter squared. Okay, let me run this on number 2 because number 2 is number, let's see what it gives me. 1. Counter, oh, counter starts from 1. And then it's for num in args, counter equal to, use num Let me see if this gives us something different. 4. No, this is not what I want to achieve. Okay, so basically what I want to do is, let me see if I use another function. That function is not what I want to get. So let me use another function called, let's say I want to let's multiply each item in the list by 2. All right. Okay. So let me say map. All right. Now this map will ask me for a function. Remember, it requires a function. What I was trying to do was to create a function for it, but I think a lambda will work best here. So let me see what a lambda can do here. The function that you would apply would be, let me see, lambda x, all right? Which gives us x raised to power 2. Okay, so okay, let me do this. Let me reduce this to one item. Let me call this 1, and then let me call this 2. And then later I would number 1, number 2. Oh, okay, yeah, I got that. All right, so lambda x raised to power 2, all right? And then what are the iterables I want to run it over? So I'd say apply that to number 1 and number 2. Let me see if this works. Okay, so let me print this and see what it gives us, and also make it a list. Before I print, let me make it a list. Now let me see what we have. No, and expected. Okay, let's see if it gives us what we have. Okay, yeah. So you can see what the function has done. In this case, what the function has done is, we've told Python, when we say map, what we're trying to do is run this same function over a lot of items that are similar, all right? So that we don't have to keep applying or calling the functions one by one. So when we do that, like this one says, take the x, which is what we have here, all right? And then multiply it by 2. So that's why you have this in 2 places. So this item becomes double, all right? So what I'm going to do is, I'm going to create more examples about lambda and map, and then some other built-in functions. I'm going to do, let me just note it down here, zip, map, filter, which other one should I do? Okay, I think these 3. So with these 3, I would be able to show all the examples that needs to be shown for zip, map, and filter, and then how to use them with lambda. I think that's something like that. Yeah, right. Okay. So please, the session is very quiet today. No questions, no interaction, and I'm very worried.
We're still here, but just no questions.
Okay, okay. So but is it straightforward? Does it help? I just want to know if I have confused you so that I can go and get better
I-
examples.
I'm not clear yet on, it's still why you would define a function versus Lambda. They
Okay.
seem very similar to me.
This one, right?
Well, just in
This
general.
map, right?
You talked at the beginning about, Lambda doesn't use as much machine memory. Defined
Yes.
function is going to stay in memory.
Right.
But it seems Lambda is doing the same thing, and
Exactly.
that's what
Lambda
I'm
is a
not
function.
understanding.
Yeah, lambda is a function, and this other function you create is a function too. But you see this now, the moment Python runs this, Python throws this away because, I mean, it doesn't store this in its memory. But if I use this function that I created here, inside of here, Python will have to create a space in this memory for this function. If I remove this lambda right now and use this function in place of this lambda, Python is going to have to create a space in its memory. All right, so that any other time somebody calls this multiply function, Python knows, hey, somebody's calling this function. But without having to use a function explicitly named, I just put in a lambda here. Python knows what we want to do is at that point in time, we just want to do something, you create an anonymous function, usually to serve one of these zip map filter. There are about 6 of them that require other functions to work. All right. In fact, sometimes it's used in decorators, generators, and all of that. So what we just want to do is to tell Python, hey, instead of putting a regular function name here, which is still the same as going to work, but it's just going to have an imprint on the memory, why not you just use an anonymous function? We'll tell you the same thing we want to do. Again, these are the parameters and this is the return value, but this time we don't want you to store this in the memory. So that's basically the difference. But everything a regular function can do, a lambda function can do it.
But if you have to rewrite the Lambda function,
Yes.
if you were to use it again,
Okay.
and define a function, the advantage of that is, okay, all you need to do is type in multiply, and you can
Exactly.
use multiply a dozen times in the program.
Exactly. I could even do that right now. So I could just call that multiply. Let me define the function properly. Def multiply. Okay, let me do that in another line. Let me do that here. Let me call this function multiply, all right? And it takes a parameter x. And it returns, sorry, this is supposed to be multiply. And it returns x times 2. All right. So let me put that in a list and a map function here. So all I just need to do is say map multiply, and I put the number 1 and number 2. Sorry, and you notice that I'm putting them in a tuple because when you have a list of items like this, you want to put them in a tuple when you're using a function or making reference to them inside of a function, right? So, so now I'm going to put that list here again so that it's going to create it as a list for me. And here, so when I run it, you'll get the same exact thing that we'll get. So you see here, lambda, you see here, multiply. It's exactly the same thing. But the problem now
Right.
is that
So
this one, yeah. Go ahead, John.
Yeah. So instead of using Lambda,
Right.
and maybe I'm not thinking on a large enough scale here of what the full Lambda capabilities
Okay.
are. in
Right.
your bottom function where you've got multiply,
Right.
okay? I
Yeah.
see how the definition, defined function, you can now use multiply throughout. But
Yes.
if all you're going to do is use that function once,
Right.
instead of calling the function, can you just
Right.
put in x squared there instead of multiply
Right
and
here.
not even, yeah, not even use the
Okay,
lambda
so
function?
okay, so let's do this. So you see Python has a problem because
Yeah,
right
yeah.
here, yeah, is expecting a function. So
Okay, that's what I was getting confused with. I was trying just to go even shorter and put that equation right in there, but it requires the function as the call.
yes, map
Okay.
will always require a function. That's here. So that's where we use all the lambdas. We use them for to support most of the inbuilt functions and decorators that require functions to run. So always create those lambdas and reduce the imprint on Python's memory. That's just the use, nothing special. Okay, so
Okay, yep, got it. Thank you.
All right. So in the absence of any questions, I'd say we are done. If you guys approve, and yeah, you have the collab, so feel free to download a copy of the collab for yourself, play around it, ask questions, and I will be glad to reach out to you on Slack, on via email or anything. All right. Yeah, Kasim, thank you. So thank you, everyone. I think we will just call it a day. So yeah, blessing, John, Kasim, thank you guys for showing up.